Well, hi there, sports fans. Welcome to another exciting edition of Physics 12, and today's lesson is 2.7, which is on advanced inclines. So we're going to take what we did with inclines and take it a step further and look at a little bit more of a complex kind of problem. So this is a typical sort of a problem that you'd be looking at. And so in this case, as you can see, we've got our inclined plane here. We have one object that is sitting on the slope of the plane, and then we have another through a pulley that is attached by a string through the pulley to the other object. And so we need to analyze this kind of a situation, and we need to find the force of friction on this object here, the acceleration of the system, and the tension in the string. So the information that we have is we have the angle here, which is 40 degrees. We have the mass of this object, 10.0 kilograms, and the other one is 4.0 kilograms. And we also have the coefficient of kinetic friction, which is 0.10. So we need to find force of friction, acceleration, and the tension. Well, the first thing that we'll start with is the free body diagram. And so we need to put all of our forces on there. So we have our normal force, again perpendicular to the surface of the inclined plane. We have the force of gravity on the 4.0 kilogram object. We have the tension, and again on both objects we have tension, just in opposite directions. We have the force of gravity on this object, the 10 kilogram object. And then we'll put our gravity components, force of gravity components on here as well. So we've got our squeeze force, and we have our slide force there. And then we have, let's see, what have we got next? Oh, we also know the angle here, that's going to be 40 degrees. And I think that covers it. That should be all of the forces, plus we know the angle there. So we can start to determine what's going to be happening in this situation. Now, the thing that we don't know right away is what direction is the motion on here. We don't know that. And so we have to determine, is the slide force going to be larger than the force of gravity on here, or the other way around? So we need to find that first. So we're going to compare the slide force with the force of gravity on this object, and then we'll know what direction our motion is. So the slide force on this object is going to be Fg sine theta, and then we put the numbers in like so, and we get 62.99 newtons. So we know our slide force is 62.99 newtons. Okay, then let's compare with the force of gravity on that object, which is going to be 39.2 newtons. So now we know what direction the system is going to move, and we can put that on there. Because the slide force is bigger than the force of gravity here, we know that the system is going to move in this sort of direction. That's going to be our direction of motion. When we know the direction of motion, now we know what the direction of the force of friction is going to be. Unless you know your direction of motion, you won't know what direction the force of friction is going to be. And knowing that, then we also know what direction the acceleration will be as well. All right, so let's now go and we'll find our force of friction. Force of friction, once again, is mu Fn. And Fn now is going to equal the squeeze force. Those are the only two forces in the y direction here. We have Fn and we have the squeeze force in the opposite direction, like so. And so when we put our numbers in there, then we get 7.51 newtons. So now we know what our force of friction is. So we can put that on there. And so now that we have that, then we can write down the equation of the forces on each of the objects. So if we start with this one here, we'll make this our positive direction here. So we'll call this positive, so obviously the other direction is going to be negative. And so the forces on this object then, we have a slide force in this direction, we have friction in the other direction, and we have tension in the other direction, and that has to equal 10.0 times the acceleration of the system. Now let's get our other object here, and we'll get its force equation. So again, this direction is positive, so tension will be positive here, and force of gravity on here will be negative, and that has to equal 4.08. So let's add the two equations together, and once again, our tensions, they cancel out like so. And so we're left with slide minus force of friction minus the force of gravity has to equal 14A. And so when we do the calculations, put the numbers in, and we get our acceleration is 1.16 meters per second. So once again, you're starting with the all-important free body diagram. And the first thing we had to do was determine the direction of motion, and once we had that, then we could continue on with the problem. And so that answers, one more thing. We need to determine the tension in the string. So once we have our acceleration, then we can go back to one of our force equations. And this would be the easiest one to use now. The tension minus Fg from this one here has to equal 4A. And if you put the numbers in there, we get tension minus 39.2 equals 4.0 times the acceleration. And so we get tension equals 43.8 newtons. All right, so again, that's how you handle a problem like this. And also, it also utilizes adding the two force equations together, which cancels out the tension, which then allows you to determine the acceleration. And then once you have that, then you can go back to one of the force equations and determine what the tension is. Now, just one other type of a problem that you'll see as well. And unfortunately, we do see these kinds of problems where the applied force on an object on an inclined plane is not parallel with the plane. And so, once again, we have to deal with that. And the way we deal with that is, again, if we just start with our free body diagram here, and we put all of our forces on here, then what we have to do is we have to take the applied force and also find the components of the applied force. You need to use a little bit of a geometry here once again. However, if you work this out carefully, you've got to be careful of your angles here. But using proper principles of geometry, you will determine that if this angle is theta here, we know that this angle is theta, and also this one is theta as well. And so, again, you need to go back to your geometry sometimes and use some of those things that you've learned from way back when. And so the way how this affects this sort of a scenario is it's going to affect the friction force, and it does so because of this. The force of friction, as we know, is defined by mu Fn, and in this case, Fn is going to equal the squeeze force plus the x component of the applied force. And it sort of makes sense intuitively, because what's happening is, if this force is being applied in this direction, it's going to affect the squeeze or the force between the two objects there, which means that it's going to affect the force of friction. So in this case, the normal force is going to equal the squeeze plus that x component there. And so that complicates things a little bit further. But once again, if you use the word I'm looking for is concepts that we've been looking at already, then it doesn't really complicate things a whole lot more. It just means that there's more calculations for you to do.